Hello everybody, this is Peter the Rock. It's Sunday the 29th of June and I'm on a footbridge. As you can probably see, some of you who've seen more of my videos might even recognise which footbridge. Sunday the 29th of June is a day that only happens not once a year but once every 7 years as the days rotate around the dates. It also happens to be St. Peter's Day, St. Peter the Apostle. The same name as me, he obviously got it first, and upon him the church was founded. I don't claim to found or find any churches, but it's just a nice day to be called Peter. And anybody called Peter watching, say hello in the comments. Anyway, today, besides the coincidence of it being St. Peter's Day, there's a lovely butterfly moving around. Actually, you know, filming butterflies is the most difficult thing. Even David Attenborough would struggle to capture butterflies. By the time you got the camera ready, they've gone. They've fluttered by. What I want to talk about today is a little bit of science. I don't want to bore you with it. But equations in science. Now, some of you will be familiar with perhaps the most famous equation of all, which is E equals mc squared. This relates mass to energy, and ultimately is the reason behind why hydrogen and atomic bombs make such a big impression, because a small mass is converted into a lot of energy. Hence the c squared factor. So E equals mc squared is a famous. Here comes a train. I thought if I rabbited on long enough I'll wave. Will he beep? No. A train would come and spoil my discourse. This is why I didn't become a university lecturer in physics, because of train interference. Although I imagine most of the lectures would probably be inside in a lecture hall. Anyway, E equals mc squared, perhaps the most famous formula. If we're looking at the relationship between electromagnetic waves, electricity and magnetism, one that is not in common parlance is curl E equals 1 over c partial diff of h by dt, which is the relationship between electromagnetic wave and magnetism via the speed of light. They are linked, and anyone can see this. If you move a magnet through, move a bit of iron through an electric field, it will magnetize, and vice versa in the opposite way. That's enough of those formulae. What I want to mention now is perhaps the simplest formula of all, and it's the second law of thermodynamics. Now, those of you who haven't turned off already, I will explain. It's a very simple formula. It's ds greater than or equal to 0, which in layman's terms stands for entropy always increases. Now, the clue is in the word thermodynamics. Thermodynamics is a science of thermo, which is heat, dynamics, moving. If you put a hot object into a cold dish of water, the heat will transfer from the hot object to the cold dish of water, and they will eventually attain the same temperature. You can't do that in reverse. So this formula really says that we're all doomed. Any thermodynamic reaction, and crikey, there are enough of them, trillions of them going on even at the atomic scale, will end up in a loss of structure or uniformity or heat or the original status. Let's put it that way. I'm putting it that way because I don't I don't know a better way of putting it. Now, we've seen a train, we've heard 2 or 3 formulae. One last thing I want to talk about now, if your eyes and ears haven't glazed over. Do ears glaze over? I just don't know. Is the Great Pyramid of Giza. Now, beneath me is the railway line Met Line from Chalfont and Latimer to Chorley Wood and vice versa, and also Chiltern Line trains come along here as well. And the last thing you'd expect when you're on one of these trains is to encounter the Great Pyramid of Giza. Now, here it is. Now, people will say to me, I can almost hear your objections now. If I put a finger in to get the scale of it, you can see that it's actually quite small. And it's not an optical illusion. It really is small. People who've been visiting Egypt for thousands of years to look at the Great Pyramid have seen a much bigger one. What I say to you is this. Doctor Who has a bit of science now and then. Here comes another train. I'll wave at him as well. Hello. Again, he didn't wave back. Doctor Who travels around the place in a Tardis. And very early on, the first series, back in '63, it was explained that Tardis stood for Term and Relative Dimension in Space, which is a meaningless acronym. Anyway, everybody says, and it's a running joke, it's been running now since 1963, oh, it's much bigger in the inside than it is on the outside. And over the years and series and doctors, the inside has got bigger and bigger. People ask me, if the TARDIS is so huge inside, and rumour has it it's powered by a sun that's just about to go supernova, it must weigh trillions upon trillions of tons, squillions, quadrillions, whatever. So if it landed anywhere, it would immediately sink through the floor and end up at the centre of the earth, which would be no good for the drama. Well, I say to you this, the inside is not in our three space as we know it. It's outside. So its weight doesn't affect us at all. That's how it works. And the same could be said of the Great Pyramid of Giza. Now, I can't prove that this is the Great Pyramid of Giza. I also can't prove it's not. Any of you watching this from the Great Pyramid of Giza, please, film it or mention it in the comments. But the Great Pyramid of Giza weighs millions of tons, and to pick it up will obviously be impossible, whereas this one can be picked up, as I demonstrate. Therefore, it could be the Great Pyramid of Giza, but its weight might be outside our 3 space or 4 space if you want to be flash. That's enough for today. You've done 2 trains, 3 formulae and a Great Pyramid of Giza. How many other people on YouTube can say they've done that on St. Peter's Day over the Chiltern Railway line? I think not many. Thanks a lot for watching, really appreciate it. More fun and games in following episodes. Like and subscribe if you haven't so far. Cheers!